Welcome to part 1 of my process for making a wool-on-wood animatronic. For this video, we're talking about arms. They're what people will be primarily interacting with when this piece is on display, and they serve as the primary indicator that it's a quote-unquote living creature. The whole structure has 3 arms in total that consist of a series of 3D printed discs on urethane tubing supported by Teflon-coated braided steel cables. We're going to cover some of the mechanics of this sculpture and get a peek into the future wiring to get this project in motion. First, we'll start with the discs that are 3D printed from a combination of Newman Library Makerspace printers and a Bamboo Labs printer in the Library Animatronic Studio. They have a 20% infill and are scaled such that the inner diameter for the middle hole is under 1/4 of an inch, so that it gets a tight grip on the tube. This is not the case for the lower discs, which I had initially planned on having an 1/8 of an inch tube for, but I made a later decision to hook the arms up to a planned central bellows in the center of the sculpture, so I drill pressed them out to the appropriate size. A quick note is that this is fine for the central hole, but the cables should have the walls from the 3D print in order to prevent the sawing action of the cables moving from generating a faster than anticipated disassembly. So with the discs printed, we want to get the first one set up on our frame mount. This is made of wood and involves some iterative work on my sculpture frame. For the purpose of the discs, all we need to do is screw the wood block onto the 2 unused holes right here, and then drill press a central shaft for the urethane tube. The arm only has 1 upward motion, so I'm able to do this. If I wanted to move it from side to side, I would need to take a more custom mounting solution and screw that onto the block. With that done, we can start placing the discs on our tube like one would with beads on a string. Really quick, let me talk about the 2 arm segments. There is an upper collection of arm discs which have 8 cable holes in total, and then a lower collection with only 4. This leaves the door open for me to expand the range of motion on the arms if I want to, but it also complicates the assembly just a little bit. In a perfect world, you would assemble the top and bottom separately, and then connect them together. Typically, the upper cable is also not polyurethane tubing, but some other shielded steel cable. But for airflow, my tube is not segmented, and it's also hollow. So instead, I'll assemble the top and then string it, and then I'll assemble the bottom and string it as well. In my case, I don't need all the supporting wire, so just the front will do, and then I can use the side connections on the lower termination point to further secure the arm and get more control on how the arm rises up into that position that I'm looking for. There's also some time that's required to let the tube relax from its coiled position and straighten out, so I anticipate that as it does, I'll need to loosen and tighten the cabling. Luckily, they're just held in place by some cut-up deck nails, so it's pretty simple to pull them out and make any of the necessary changes. The last part of the arm is a single cable that runs from the top to the bottom through each disc, and that's going to give it this nice motion that we see right here. For now, that's all we have in terms of mechanics, so for the next step, I need to finish up the third arm and then start to wire my electronics together. I have a Arduino Uno Adafruit servo driver and a human presence detector radar, which will be used to trigger the motion of the arms from that relaxed position to that active position. This all happens through a single 35 kilogram servo motor, which has a wheel on it, and each arm's main cable, that cable running from top to bottom, is attached to that. Here's a wiring diagram of what I have right now. It's hand-drawn, but you can kind of get the idea. We can see that it's pretty simple to hook up and that the whole structure is powered by 2 6-volt 1-amp wall AC to DC plugs. This has some room for some later expansion to addressable LEDs, and also I need a second servo for that bellows, but they're not going to be in this segment of the project. Lastly, here's an in-progress assembled version that I displayed at a pop-up exhibition in late October, so we can get an idea of what it'll look like when it's finally all dressed up. And that's it. So thank you for watching. Hopefully you'll catch me in the next one.